Okay, this is a new chapter, chapter 11. It's called Law of Sines. So it's 11.1, day 1. And for law of sines, first of all, what is it? Let's write it down. If you have a triangle set up where angle A and little a are across from each other, and angle B and little b are across from each other, and angle C and little c are across from each other, then even if it's not a right triangle, we've got this cool formula that will work. Little a over sine big A equals little b over sine big B equals little c over sine big C. Now, there's nothing magical about these letters. Later on in our homework, they're going to start calling big A alpha. So just so you know, alpha is just a different way to say A, right? And so instead of using a capital A, they actually use a little alpha and a little a. And then for this B, again, they're going to switch this out for a big beta, which is a Greek letter. And then the third one, the C, they swap it out for this thing, another Greek letter. Kind of looks like a V, like a scripty V kind of a thing. So all I'm saying is, just don't be shocked when later they change the letters on you. It's the relationship that's going to hold true. Okay, so now how do you use this thing? Imagine for a moment that the way I drew this thing, this is 100 degrees. And let's say that this side over here is, oh wait, just for a second. Do you get, in a triangle, it has to add up to 180. Could you have two angles that are bigger than 90? If you had 91 and 91, it'd add up to 182. That's impossible, right? So the point is, if you ever have a big angle, then that big angle, there's only going to be one of them. You can't have two big angles in a triangle. That doesn't have anything to do with right triangles. It's just about if you have any angle bigger than 90, then it's the only one that's bigger than 90. Okay. And I personally am going to use that the C, the little c and the big C are always going to be the biggest angle. You know, in the ABC in a triangle, C was always the hypotenuse, and that was always across from the 90, which was the biggest angle. So it's kind of like that. But then the A and the B, they can be either one. I could swap this, make this B, and then this would be little b, and make this A, and this could be little a. But I'm going to always use that the biggest one is C. It doesn't have to be that way, but I just want to warn you as you're drawing your triangles, that's a way to think of it, that the biggest angle, there's only one of them, and I'm going to always call it C. Okay, now, so far, all I've told you is C. So I could put 100 right here. You get I don't have enough to solve anything because I still got variables all over the place. If I just look at this part of the formula, for instance, do you get I will need 3 out of 4 parts to be able to solve it? I'll need to know, like, let's say I knew this was 10 or something and this was 6 or whatever. I would now have only one variable and I could solve it. So I need to get 3 out of 4 parts in any set of 2. And I got to be careful with that because what I first said was you just needed 3 things. But do you get, if I give you, this is 100, and this is 4, and this is 6, and this is 8, I've even given you 4 things in, oh wait, actually that would be enough. Sorry. If I had 4 things, then it will be enough, always. But if I have just 3 things, you can arrange it so that you have 3 things but still not enough if I don't have any that go together. Like for instance, let's say that one's 100. Let's say this one's 12. I don't have enough info. Like if I make a box around these two, I don't have 3 out of 4 parts. Even though I have 3 pieces of info, I have it in such a weird way that I don't have 3 out of the 4 parts. Like there, I don't have 3 out of the 4 parts. And even if I stretch it and go this with this, I don't have 3 out of the 4 parts. Okay, so the point is sometimes they don't give you enough info to solve it, and sometimes they've given you a triangle that can't exist. That's what makes this pre-calc. Otherwise, this would be like geometry. Okay, it's pretty easy stuff, but you got to be able to handle it. Sometimes you don't have enough info to solve it, and sometimes they've given you false info that can't make a triangle like they said. I'll give you an example of one. Let's say I said this was 100, this was 8, everything's possible so far, this is 10. I have given you impossible information. Why? How can it be? What? What side's too big? This side. Don't call it CB, call it the little letter. A can't be 10. Why? Yes, except it's not really hypotenuse. But the biggest angle has to go with the biggest side. Does that make sense to you? And it doesn't right now. But could these be reversed? Yeah, then that's possible. Now, the biggest side here, 10, goes to the biggest angle. That relationship always has to be right. The biggest side will go with the biggest angle. Okay. So, again, now I've drawn something that may be possible again. And you could solve. I have given you 3 pieces of info, and unless you're unlucky, I probably gave you 3 out of 4 in a block. All right, I would like you to see if you can find angle A from what I have told you so far. Find what angle A has to be. See if you understand this well enough yet. Find angle A. So take this formula, stick in what you know, and solve for A. By the way, hint, you will have to use inverse trig once you have it all set up. You're also going to have a proportion, and you got to remember how to cross multiply. Like if you have 4 over 6 equals 5 over 9, x, you cross multiply. 4 times x equals 10, and you solve like that with cross multiplying. All right, I'm going to pause for a minute while I give you a chance to try to solve for A. Big A is what we want. Okay, let's get the dice to tell me who's going to help me set it up. You don't have to be done yet, but at least you should have something set up. Roll 1, last person. Tell me what could I put into this formula. I'm going to leave the formula here. You tell me what to stick in. Okay, so you're saying I don't need the middle part. I agree, and you don't have to have the middle part. Some kids were like, what do you mean you don't need the middle part? Well, do you get that if that equals this, and this equals that, then the first one has to equal the last one too, right? All right, I agree. We don't need the middle part for this one. Okay, so tell me stuff you know. So what's little a? 8 over sine of A. Good, and I'm going to leave this as an A because we don't know what it is. Go ahead. 10 over sine of 100. Perfect. And then you just cross multiply. 8 times sine of 100. Do you have that for me yet? Go ahead. Type that puppy in. You do 8 times sine of 100. I'll do the other part. 10 times sine A. 10 sine A equals, what was 8 times sine 100? I 7.9. I agree. It rounds closer to 7.9. Raise your hand if you got something similar. Okay, good. If I'm going to get this A alone, I got to now divide by 10, and I can divide by 10 in my head. You guys know what that happens when you divide by 10? Decimal goes over 1. Sine A, 0.79. How do you get that sine off of there? Inverse sine on both sides. And this cancels. So A is inverse sine of 0.79. And random person, if you all haven't got it, you should be typing. Inverse sine of 0.79. It is row 6, person 4. That's you. 52? Raise your hand if you had 52. All right, good. So, do you get, now that I have 52 degrees, everything else will start to fall? That's 52. And, ooh, 152 and something have to add up to 180, right? You don't need any complicated formula to do that. You can just use your brain and go, I'm going to add up until I get to 180. So if I added 30, oh, that'd be too much. 28? Have I got that right? All right, cool. So that's 28. And then the last one is this side here. Well, you can set up and now use this middle part to find B. Everybody do that. Figure out what B has to be now. B over sine B. Well, we know B is 28. So hopefully you're doing sine of 100 times B. Actually, that's little b. Equals 10 times sine 28. I get 4.69 for sine 28. Can anybody verify that? All right. And sine of 100b, I got to now multiply or divide both sides by sine of 100. So now I'm going to take 4.69 and say divided by sine of 100. 4.77. Raise your hand if you had the same thing as I did. Okay, cool. All right, that's how you use the law of sines. That's all there is to it. Do you get that if they give you some info, they might not be giving you enough info? Okay. All right, you tell me enough info or not. Here's a problem. It's going to be just slightly bigger than a 90-degree angle. It's going to be 104 degrees. And this is 10, and this is 3. I'd like to know if that's enough info or not. Would you agree it's supposed to be A over sine A, B over sine B, and C over sine C? And now I suggested we always pick the biggest angle and call it C, and then we'll call this little c. And then I don't care which one you want to pick. Let's call this big B, and then that's little b. And let's call this A, and then that's little a. So then A is 3. B is 10. And the angle C is 104. Now that I have it written in red, do you see any spots where you have 3 out of 4? No. And here's a way that you can know easier than that. You always need an angle and the side across from it. Do you get if I had any two that are together, like those two together, then automatically if I have one more piece of info, I got enough, right? Or if I knew these two together, or if I knew these two together, if I knew both C and sine of C, then I have enough info, as long as I have one more piece of info. Okay, so what you look for, experienced, and you will be experienced eventually at this, you're going to go, oh, not a good case for law of sines, because I don't have an angle on side across from it. By the way, what do you think works that? Law of cosines, very good. And that's what you're not tomorrow. We have actually one more day on law of sines tomorrow. And then the next day you learn law of cosines. That's where you can still solve it. You just got to use law of cosines. Okay, so let me show you one more thing, and this is complicated thing called the, let me show you the little formula that goes with it. It's, right. Should have paused it, but here. Love, signs, concerns. Go to that one. Now, I think that you should just think about this for a moment with these numbers. Let's say I said this was 8. Let's say I didn't know how long C was, and I knew that A was 1. And let's say that I said this was 30 degrees. I want to know, is it possible that I set up an impossible triangle? Is it possible that this is just too short to touch? See what I mean? Well, how could we figure that out? Well, we could act like this did touch, and then do you get, we'd have a 30, 60, 90. Okay, and in that kind of a triangle, do you get that this blue side here would have to be 4 because of the whole relationship where this is double that? Does that make sense to you? Okay, so do you get that if the blue one here would have to be 4, that 1 is way too short? Do you see how that's an impossible triangle? That's what they're trying to tell you with this stuff. But I don't need you to memorize that big list of things. What I need you to be able to do is think, how long would it be to be just right? That's kind of like the Goldilocks length. Okay, and you just figure out how long that length would be. And if it's shorter than 4, do you get that that side couldn't touch? What if it's longer than 4? Could the side touch? Yes, let's say it was 4.5. If the dangly side here is 4.5, do you get that it would touch and it wouldn't be making a right triangle? And if this was 4.5, that there'd be some other way to make it touch that way, that would also be 4.5. You see what I'm saying? You could swing that side out to the right or to the left, and then we don't know if it's this triangle, if it's 4.5. We can't tell if it's going to be this triangle or if it's going to be this triangle. So it's called the indeterminate case. Indeterminate meaning like I can't determine whether or not it's going to be the green triangle or it's going to be the pink triangle. And the thing that's cool about this is there's so much symmetry going on that if this side is 4.5 and that side is 4.5, do you get that these angles have to be the same because the angles and the sides across from them would have to go together, right? And then let's say I told you that this was 70 degrees. Do you get then that that has to be 70 degrees over there? And those become really easy to do with a law of sines. All right, so the point of this is that there are some triangles that are kind of fishy, where they don't work. And here's what to watch out for. Do you remember side angle side? Side angle side works. Do you remember that that's a thing you could do to prove two triangles were the same? What was another one that was kind of like that? Side angle side. There's angle side angle was another one that worked. What was the one that didn't work? It was kind of a pain. Angle side side. That's correct. And that is the same one that'll still give you trouble. And they're kind of a pain, if you know what I mean. So here is one where I have an angle. I don't know how long that side is, but I have this side is 8, and this side is, I'll make it a little longer. Let's say it's 6. I want you to figure out, is that a possible triangle or not? Remember what I said? Figure out what the Goldilocks angle would be. Goldilocks side would be. The one that would fit just right to make it a 30, 60, 90 triangle. Figure out how long that would be. Is it long enough to touch or not? If I drop this straight down to 30, 60, 90, that's the 30. Then my brain works like this. Okay, across from the 30 is the smallest side, and this is the 8, so that would have to be a 4. How many of you got that figured out? Okay, and if that's a 4 and that's an 8, then the other one is, well, I'm going to draw my little perfect triangle next to it, the 30, 60, 90, in the same orientation as this one is, and this is a 1, 2, square root of 3. Then I can see, oh, this is 4 times bigger than that one is. So then this would be 4 root 3. And then I grab my calculator and I'd type in and see what 4 root 3 is. 4 times the square root of 3 gives me 6.9. That side would be 6.9 if it was just right. Is 6 going to work or not? Nope, it's too short. What if it was 7? Could 7 work? Yes. Would it be the perfect Goldilocks triangle? No, it would be the indeterminate case. If this was 7, where instead of 6.9, it'd be just a little too long. And then it goes past it, and then either it has to swing this way and makes that triangle, where this bottom side's longer, or it would have to swing that way and make a triangle where the bottom side's shorter. Because we don't know what that's for sure for. That would be the Goldilocks triangle. Okay, so moral of the story is you can have triangles where they don't work. You can have triangles where they work just right to make a right triangle. And you can have triangles that'll give you 2 separate cases that you can't figure out. All right, now I've kind of taught you both today and most of tomorrow. So you're a little ahead. Law of signs is the thing for today. So let's go and do some of your homework on law of signs. Everybody find the first one where it says day 1. I want you to draw it, and I want you to label it, and I want you to think before you just dive into the law of signs. Draw a picture of it first. I'll pause while you give that one a shot. Okay, so to get started on drawing this, I know we're so used to right triangles, a lot of times people do that, but that's impossible. Why can't it be a right triangle? Because there's a 117-degree angle in it. It says so. So I'm going to put a 117. I don't know what a 117 is, but I know it's bigger than 90. There we go. There's a 117, let's say. Okay? And next is the side across from that, this is alpha, is 35. And I know I said I usually pick that to be C. Did I say you could do it the other way? Yeah. So far, nothing illegal. Then they want me to put inside B. I don't care. Pick one. I'm going to pick that one to B. That this is 42. Does anybody see a problem? Yes. There's a problem. What's the problem? The biggest angle is supposed to go with the biggest side. So that's impossible. You could have done the whole thing and figured out answers that are completely bogus because you can't make that triangle. Okay, so this is just no solutions. And they'd have to say these two would have to reverse or something like that. Just to say why it's impossible. Shouldn't just say impossible, impossible why, because. Or you could say biggest angle isn't across from biggest side would be a good answer. Okay, moving on to number 6. I will tell you it is basically the same angle, except they did reverse them, and now it is possible. And again, they said that's alpha. Then they said this is 45. And then B, I'm going to pick this to be B down here. And then I'm going to say the little b is the line across from it. This is 42. And yeah, you can figure out all the answers on this one. First thing I would do is write the formula. A over sine A. And then I just use my iPad's ability to erase perfectly, and I would erase stuff and stick things in. B over sine B. And C over sine C. Okay. Alpha is 117, so I'm going to put, remember I said alpha and A are going to get interchangeable? That's 117. And the A is 45. Putting a 45 where the A used to be. And then I know little b is 42, so I can put that right here. And cool, I got 3 out of 4 spots. That one I can do with cross multiplying and solving. Okay, and your job is to find all the other sides and angles. I know that's not clear in the directions, but that's what you're supposed to do, is find all the other sides and angles. And once you have one of these angles, like we're about to find B here, and if I knew that was like 38, it's really easy to find the last angle because they have to all add up to 180, so it'll be a piece of cake. All right, so you are skipping problem 10 because it says extra practice. If you need extra practice, feel free to do it. And we are also skipping one more, this one, number 29. It's nothing wrong with it. It's a good question. It's just I don't feel like we need that much extra practice. Now, to me, those are awesome problems to save for the night before the test. Do one of those as your practice problem. You know, sometimes one of the complaints we get from kids is, what am I supposed to do this night before the test? Well, I give you some skips. Maybe go back and do those. All right. This, again, is that big, long description of what happens when the one side's a little too long compared to the other. And you'll have that, oh, this is an impossible triangle, or oh, this is a perfect right 90-degree triangle, or actually, there's 2 possible triangles. All right. So again, you're skipping problem 10 and the last one. All right, that's all I got for you for today.